So I think possibly the very best part of this one is the fact that they use the word whilst. It just makes it all worthwhile to me. Sorry. So this is definitely moving source, right? The airplane's emitting this frequency, and we want the wavelength of the sound in front of and behind the airplane. So the short version of this is that we're going to use, though, at the moving source formula, which is this, right? And then this is the speed of sound, and then it's going to be v plus or minus the velocity of the source, right? And we're going to use both plus and minus. I think minus is in front of the plane because it's a higher frequency, and plus is behind the plane. But it'll be obvious once you figure out the frequencies, right? And then once you've done that, we'll use v as f lambda, right? Once we know the frequency in front of the plane and behind the plane, we can just use this formula. This is our velocity, and we can figure out those wavelengths, right? So let's do this. Divide up our space here. Don't want to run out of space, right? So in front of the plane, I think it's going to be something like this, right? Our shifted frequency is the original frequency, which is 142. The speed of sound is 324. Keep in mind that IV is going to give you all sorts of different speeds for 324. And then let's see, we're in front of the plane, in front. So in front of the plane, the frequency is going to be higher, right? So I think we go minus 92. Because that'll make the denominator smaller, and that'll make our answer bigger. Okay, so our frequency in front of the plane is 142 times 324 divided by, parentheses, 324 minus 92. And sure enough, I get 198.310. And that's in front of the plane, right? Let's go behind the plane, right? Our frequency, our shifted frequency is going to be 142, which is the original frequency, right? Times 324 over 324 plus 92. All right, we can do this. Now I may just be going second entry and changing the minus to a plus. That might be what I'm doing, but you just don't know. 110.596 hertz, right? And this makes sense. So behind the plane, lower frequency, in front of the plane, higher frequency. All right. And then we want to find the wavelength. So the wavelength, we're going to go v is f lambda, and we'll use this as our f, right? Okay. So v is f lambda. So the speed of sound is still 324. Then our frequency is 198.310, and then lambda is what we got to find. So 324 divided by 198.310 is 1.633. So in front of the plane, it's a shorter wavelength, right? And that's, of course, because what? Here's the plane, right? You've got the wave front, right? And then here, the wave front. Here, the wave front will be like that. Okay, so in front, because the source is moving to the right, it's shortening those wave fronts, and behind it's lengthening them. And then here I'm going to do the same thing. So I'm going to go V is F lambda, right? And so 324 is equal to 110.596 times lambda. So we can just divide that. We go 324 divided by 110.596. We get 2.929, so 2.93 lambda is 2.93 behind. It's going to be bigger, right? Because we're flying away from it, right? Now, this is all well and good. This is how I would expect you to do it, right? Because you can find the frequency. We can use this to find the wavelength. Let me suggest an easier way to do this. But, again, this might be confusing, so stop listening if you already understand this. But if you want to know an easier way to do this, keep listening, right? So what we can do is we can find, let's suppose the plane doesn't move, right? The wavelength is just V is F lambda, right? Okay, so lambda is just V over F is 324 over 142, right? This is meters per second. That's cycles per second, right? Okay, so 324 divided by 142 comes out even to 2.281. I'll just round it to a 7 meters, okay? Now, the airplane moves, okay, in one cycle, right, in 142 of a second, okay? It's moving 92 meters per second, right? So the distance it travels, this is the time, that's the period, right? I'm using the formula, what period is 1 over frequency or something like that. I think that's in the data packet, right? Okay, so that's the amount of time. It's going 92 meters per second. So the distance it flies between one of these cycles is just 92 times 1 divided by 142, right? So it actually travels 0.6479. Right? So that means in front of the plane, it's shortening this thing, right? It's shortening the wavelength by that much. And behind the plane, it's lengthening it by that much, right? So we can just do this, right? In front, it's going to be shorter. Right? So 2.2817 minus 0.6479. Let's try it. 2.2817. Did I type that in right? Yes. Minus 0.6479. Indeed, I get 1.63. Right? And then in behind, it's longer. Right? So it's going to be 2.2817 plus 0.6479. So 2.2817 plus 0.6479. And indeed, that's 2.93. So just think about that, right? If it didn't move, it'd be right in the middle. The wavelength in front and behind would be the same. But because it moves to the side, some amount, this amount, right? It's shorter in the front by that amount and longer in the back. Kind of like a mullet.